So we'll have another 30 minutes this period. So this is lecture number 24. And again, today's date is 03/04/2021. So far we have done quite sufficient number of problems on blocks on slope. That single block, or it is the connected blocks, or it is constrained block, or it is instead of a block, if I have a cylinder or drum, then there can be a chance of tipping. So this all quite number of problems that you've solved. You are also recommended to go through the textbook Weir and Johnston. There are many number of problems on this topic, blocks on slope. Please go through them and have your understanding concepts clear. So with that, let us now continue in this period with an interesting topic called wedge friction. So So what do you mean by wedge? What is wedge? So wedge is something, a triangular shape member like this. So this is what is called a wedge, this piece. So this can be supporting heavy load, and it can be used for adjusting the heavy load by applying relatively a smaller force. So that is an advantage. So this is again a mechanical element. You could see these wedges are always placed underneath the heavy loads, so that these wedges can be used to rise or lower that load or adjust the load, right? So how do you have a simplest case of a wedge? So let us take a problem for that to understand. Right. So look at here, I have heavy load represented by this block like this. Where top surface is flat and bottom surface with some angle, and this angle is relatively a smaller angle, where you would see such kind of wedge pieces there supporting it, right? So this is that arrangement of wedge. So this is there. So now you see this entire thing is supported like this. So one side of this block is supported against this wall, vertical wall, whereas this wedge is now on a horizontal floor. Now you look at the weight of the wedge is normally negligible compared to that of the load it supports. Geometrically, it appears here as if this is also big volume like that. That can be, because this can be a heavy material, this is very light material. This can be wooden piece, this can be a wrought iron. So in such cases, dimension immaterial, right? So if you see that, sometimes this can be negligible weight, or it can be a comparable small weight. So in this case, consider the weight of this heavy load is 4000 Newton, 4 kilonewton or 4000 Newton, let us take. This is 4000 Newton. And compared to this, what is the weight of this? Weight is 200 Newton. See, this is small, 200 Newton. Right? So now, what is the question is, what is the force P that has to be pushing this? So this push force P can be given by means of screw mechanism again. As you turn, then that can be pushed and so on. But we do not worry about that now. So there is a force P that is pushing this wedge so that it can be raised. And in absence of force P, this should be locked. This load should not push this wedge out. That's important. So this should be locked. So then you would see that clearly. This wedge angle here, this angle is given a small angle. Take 8 degrees. This is 8 degrees. Whereas now you are also given mu s value is 0.25 for all contacting surfaces. Right? For all contacting surfaces, mu value is given this. So immediately in wedge friction problem, you should see that this is 8 degrees. This is sitting here. Whether this wedge will be holding the load or in absence of P, it will be pushed out. That can be verified by finding what is this friction angle. So friction angle is what now? The tan inverse of 0.25. So what is that you get? Tan inverse of 0.25. 14.04. 14.04 degrees. So look at here, this angle is smaller than this angle. So this would be staying there. When I apply force P, I can just rise or adjust this load. Otherwise, this wedge would just hold it and it would stay there, right? So this is what is that now wedge friction simple sample example problem and its configuration. So now what would be the question that you expect? What is this horizontal force P will be necessarily to be applied on the wedge to rise, in order to just rise the load up, So find the magnitude of force P in order to just rise the load of 4000 Newton. So that's the question, right? This is fine. So now how do you go about solving this problem? Essentially, you should draw the free body diagram, right? So you should always start to draw the free body diagram of the wedge first and load second. So now let me just draw the free body diagram of wedge and load after that. So how many contacting surfaces are there? So this one on the horizontal floor, and wedge and the load contacting surface, that's 2. And then load is against the vertical wall kept, that is 3. So these all 3 surfaces has got the same mu value that's given in the problem. So if you understood that, now let us draw an individual free body diagram first for the wedge. So my wedge angle is 8 degrees. And then the load. And then the load, I will just draw the load somewhere here. Just a minute. Take this. And we have the load here. So why do I want to have an adjacent? That's the reason. I just draw like this. Let me draw, then you will understand. So this is load. Right, so this angle and this angle is 8 degrees now. So now what are the forces acting on a wedge? You have this force P, and then the weight of the wedge 200 Newton. Importantly, as this is pushed, it would be resisted by a friction force against its expected motion, right? So I would have my friction force in this surface in this direction, in this surface in this direction, and I would have here a normal force as well. So this is my normal N. So since it is contacting surface 2, N2, and this is mu s times N2, so you know what is mu s value, 0.25 N2. And here it is N1, so 0.25 N1, and my normal N1. Right. So again, there is an advantage of combining this. In wedge friction problem, small angle, so more. See, if I combine these 4 forces, can be made as 2 forces. So I would have additionally 2 4 forces. That's always recommended. So we will combine that. Right. So if I combine that, what is that I would have? I would have here this force, which is R2, and I would have here this, which is R1. So this R1, R2 both would have to the normal the same angle. Whatever we have got, this 14.04 degrees. Here also it's 14.04 degrees. But importantly, in this case, since this surface is inclined, what is it to the vertical? If you see, this angle is already there 8 degrees. This angle 8 degrees, and this is 5s additionally. That you should understand. So now look at this block free body diagram. So this is free body diagram of a wedge. Now what would be the free body diagram of the block? Let me redraw this diagram neatly again. So that would be somewhere here I draw. So now in this I have the weight 4000 Newton, and this surface normal, right? See, the same thing should be there. This here R2, so that is opposite. So the direction also. Let us first draw the friction force, then we will do. So the direction of friction force on wedge is up. So here it is down like this, and normal is here. So this is N2, and this is 0.25 N2. So if I combine these two, I would have opposite to this same. So this is my R2, and you see the same way. This would have normal will have to the vertical. This is 8 degrees, and this would be a 14 point. So this is 5s angle. So this is my R2. So what is there here? The same would be here. And then since there is a pressure on this vertical wall side also, so I would have my reactions there also. So I will have my normal, which is N3, and it is to rise this load. So you apply force here, so it is to rise. So the friction force will act downward. So that would be here, and that is 0.25 N3. So you have again an advantage of combining these two. So this is its resultant, and this is R3, and this direction also here is 5s, which is 14.04 degrees. So now look at this load. I have how many forces? The load and the two forces, R2, R3. So 3 force equilibrium. So the dimension of this is immaterial. So that should essentially a concurrent system of force. So I would redraw this diagram in a convenient fashion as this way. So I have my load 4000 Newton, and this is my concurrent point representing the heavy load. And see this R3 to the horizontal 14.04, and it is coming down. So from here, this is my R3, and this angle to horizontal, this angle to horizontal is 14.04. Now R2 to the vertical is 8 plus 14.04 to the vertical. So let me have this. It's a vertical line, and it is now the tail. I am going to bring it here. Yeah. Who is that? Huh? What doubt? So I would have here this R2, and this angle to the vertical is 8 plus 14.04 degrees. This is R2. So from this free body diagram, now I can find what is R2, and here I know what is R2. Then I can solve for this P. So one is this free body diagram, another one is free body diagram of the wedge. So here, though I have more than 3 forces, it is better to represent the similar fashion. So here for the wedge free body diagram, you have your weight down of the wedge 200 Newton, and force P to the horizontal to the right, that's P, and R2 direction to the vertical here is 22.04. Here it's up, so it will be down here. So that is R2, R2, and that is to the vertical. So this angle. So this angle is now 22.04 degrees. That's R2, and I know this value from this, right? And R1 to the vertical, again 14.04 degrees. So that would be acting here. This angle is 14.04 degrees, and that's R1. So I have here R1 load and this P. So R2 is known, P and R1, there are two unknowns. I can solve for P here. That's all. So this is what is another group of problem where you can solve for unknown. So let's just work out quickly. First, let us work out for R2, then we will solve for P. So let me just move this free body diagram here. This is for this wedge. Let me keep it here and work out now for this applying Leibniz theorem. So Leibniz theorem to apply, I have here R2 to be found out. So R2 by sine of angle included by other two vectors. So that is this angle. So what is that angle? This angle. So this angle is now how much it is? It's 90 minus 14.04. 90 minus 14.04. So that's 75.96. Sine 75.96 degrees. That's equal to 400 by sine of angle included by the other two vectors. So what is that angle? That is this angle from here to here. So that angle would be now 90 plus 14.04 plus here 22 point. What is this angle? R2 to the vertical is 22. This angle is 22.04. So this angle is 14.04. So 14.04 plus 22.04 plus 90 degrees is what is the angle included by R3 and R2. So sine of angle 126.08. So I get what is R2. It's 4000 sine 75.96 divided by sine 126.08 degrees. So sine of answer reciprocal multiplied by 4000. This is 4000 multiplied by sine 75.96. So I get to 4,801.45 Newton. That's what is R2. So I have now R2, right? Now this R2 should be substituted here. So I know here this R2 determined 4801.45 Newton. 45 Newton. So now I can solve for P. So coming here again, here I can't apply Leibniz theorem because I have four forces, right? So I have to solve by condition of equilibrium. So I have R1 and P. So both should be solved in this case. So since P to be horizontal, so when I apply sigma Fy equal to 0, P will not come in the equation. I will be able to find what is R1, right? So considering upward positive, so R1 cos 14.04 minus 4801.45 cos 22.04 minus 200, that's equal to 0. So this component cos component, this component cos component, this. So these two are down and this is up. So you have this. So R1 equals 200 plus 4801.45 cos 22.04 divided by cos 14.04 degrees. So I would get R1 value, if I work out, 200 plus open bracket 4801.45 into cos 22.04 plus bracket, so 4650.57 divided by cos 14.04, so that is 4793.78 Newton. That is R1, right? That is R1. So now I can find out what is P. So now I can use my second equation, sigma Fx equals 0, convention to the right positive. So P plus P, and these two would be having its component to the left. So what are the component? Minus R1. So R1 is 4793.78 sine 14.04. So this horizontal component, see this angle is to the vertical, so horizontal component is in cos of angle this into its magnitude. So minus R2. So R2 is 4801.45 and that angle is 22. So sine 22.04 degrees, and that's all equal to 0. So now I can get what is the value of P. So what is the value of P? So I get P value equals 4793.78 sine 14.04 plus 4801.45 sine 22.04 degrees. So work out for this. So 4793.78 into sine 14.04 plus 4801.45 into sine 22.04. So I get 2964.73 Newton. 2964.73 Newton. So this is the answer. So you see here the load is 4000, but you don't require to really put that. It is having lesser value to be put relatively, right? So this is the answer. So this is how you solve the problem of wedge in contact with the other surface load. This problem group is called the wedge friction problem. So like screw friction problem, is locking of screw is important. Here wedge also should lock the system. So you want to lower the load, you really require to give a force P in an opposite. You have to pull the wedge out so that it can be lowered. So that is the arrangement. But for solving problem's sake, you may have this angle instead of 8 degrees. You can also be given the angle instead of 8 degrees more than this. So say some 30 degrees if I give in the same arrangement. In absence of P, this load will push this out. So I would also require what is the force of P required to hold the equilibrium, or increase the value of P so that I can rise this same. So the same problem I can ask in this way. What? Instead of giving this angle 8 degrees, if I give this wedge is of 30 degrees, so this phi is less, so it is greater than that. So it is gone beyond the angle of repose. So in case I do not have force P, configuration cannot be possible. So you require force P to prevent that wedge coming out, and then you have to increase the value of P so that you can rise the load. So the problem what we have looked at explicitly, block on slope in last period and today's first period. Similar way you can have a problem in the examination. So with that, let me stop today's lecture, and if you have any doubts, I would be happily answering. Any doubts in this? And we will solve some 1 or 2 problem on this, and ladder friction problem 1 or 2. So tomorrow, that's on Monday, we have again 1:32. 3 class, and I would complete module 3. Then on Wednesday class we will start with the module 4, right? So that is our action plan for next periods to come.